when we talked about adding and subtracting, did I have to, actually, did you have to find the domain of the two combined functions? Or could you just find the domain of one, find the domain of other, and then keep the restricted domain of most restricted domain? Yes. That's how you could do it, right? You could get the domain. So if one is XER, the other is XER, the domain of the combined function is XER. If one is x is greater than 2 and one is XER, the domain of the combined function is greater than 2, right? So it's that most restricted one. So you don't actually have to find the domain of the function if it only asks for domain. You can find the restricted domain of both. That's for adding, subtracting, and multiplying. Dividing, it's the same, but the only catch with dividing is you'll have the most restricted domain, and then you have to check for non-permissible values or restrictions, because you can end up with x's in your denominator. Okay? Range, however, for any of those four functions, you actually have to find the function and then get the range of it. You can't, there's no quick and easy way of doing that. You actually have to find the function. Okay? So we're going to look at multiplying. Now, it does matter that that is a closed dot. Do you see that there's a closed dot there? That means multiplication. An open dot on Monday, we're going to realize means composition. So it's like f of g of x. Okay. So we do have to have the closed dot. So here, let's determine the domain of this graph first. So we have x minus 4 is f of x. That is a line. What's the domain of a line? X, yeah. The cord must be loose or something. It's not happy. But I don't know what. Stop it. And g of x is x plus 4, which is also a line. What's the domain of a line? XER. So technically, if I add these, if I subtract these, or I multiply them, what's my domain? XER. We agree? That combined function part. I know this isn't part of this question, but we're just discussing this. Division, it would be XER-ish. So it starts off with XER, but say I give you f over g of x. That is the same as f of x, which is x minus 4, over g of x, which is x plus 4. So x can't equal what? Can't equal 4. That's where our vertical asymptote would be. Yeah. Point of discontinuity would have to be on the top and the bottom. It's not. So this is our vertical asymptote, right? Hence why the unit is taught last. Some people will teach it first, which is weird to me because you don't know rationals or radicals or anything, actually. So it's really hard to do. So I always leave it for last. So this here would be x can't equal negative 4. And coming into this question, it was XER, right? So really the only thing it can't equal, it could equal XER until I stack them, but now it can't equal negative 4. So my domain of this function would just be x such that x can't equal negative 4. Because it's just a rational function, correct? Which we just finished doing, rational function. And then if I had g over f of x, it now would be the opposite. It wouldn't be can't equal negative 4. It would be can't equal what? 4. So really for radicals, or sorry, for rationals for division, you can get that combined function, but then you have to look, are there restrictions? Does that kind of make sense how we do the divisions a little bit different? Okay. So for this one, we want to state the domain. So the domain, this is like a little caveat, right? We want the domain of this f times of h of x, which is f of x times g of x. So the domain we said was x is an element of the reals. And how do we get the range? Well, we have to get the function first. So h of x equals f of x, which is x minus 4, times g of x, which is x plus 4. What am I going to end up with when I multiply two lines? A quadratic or parabola, yeah. So I'm going to get x squared plus 4x minus 4x cancels, minus 16. How do I get the range of that? Go to my calculator and get a minimum, correct? Or I know that this is a quadratic. Remember your quadratic graph, your parent function is x squared, yes? Which means it's like 0, 0 like this. Boom, boom. Using transformations, what is this graph doing? Vertical translation 16 units down. So now it's like a negative 16 doing the same old thing. We agree? So what is my range? Y such that y is greater than or equal to negative 16. And then is this graph hard to sketch, x squared minus 16? No, go to your calculator, right? You can do that. It's a Friday, so we're not going to do that. All right. Okay, I want you guys to do this now based off of what we just kind of did over there. I want you to get me h of x, and I want the domain and range. Okay, let's talk about it. So the domain will be easy. The range will be a little hard because I'm going to show you something here. So we have x plus 3 over 2x minus 5. So my domain, I know from this, I have a vertical asymptote. Am I allowed to write VA on the test? No. Vertical asymptote has to be on the test. These are your notes. Can you write VA in your notes? Do you know that stands for VA? Yes, because you're reading your notes. On a test, you don't know who's reading it. Well, you know I am, but the diploma, you don't know who's reading it, right? You can't do VA. So we have 2x minus 5 can equal 0. Why do I know this is a vertical asymptote and not a point of discontinuity? Because it didn't cancel the numerator and denominator, right? Your NPVs are either a vertical asymptote or a point of discontinuity. They're a vertical asymptote if they don't cancel off, and they're a point of discontinuity if they do. So we have 2x can't equal 5. X can't equal 5 over 2. That's my restriction, but my vertical asymptote is actually x equals 5 over 2, right? Because it's where it actually exists. But that gets me my domain. Go away, little blue box. Okay. My domain in set notation is x such that x can't equal 5 over 2, xer. Now we're going to do it in interval notation to remind you of what we have to do if it's an interval. An interval is everything but 5 over 2, correct? So we do from negative infinity to 5 over 2 round bracket union, which means or negative 5 over 2 or 5 over 2 in round bracket to infinity, right? So an interval is going to be negative infinity 5 over 2 round bracket because it doesn't equal it, or 5 over 2 to infinity. Yeah? Okay, fun fact about horizontal asymptotes. So if your equation is in transformed form, so if your equation was like this, it's not, but let's pretend it was 1 over x plus 3 plus 5. Yeah? This is my horizontal asymptote, correct? Because a horizontal asymptote can be moved by vertical translation. We agree? That's transformed form. Transformed form means there's a number up here. This is where my asymptote sits. Vertical asymptote sits. This is where my horizontal asymptote sits. Boom, boom. Correct? Is this in transformed form? No. It's in full stack fraction, which means there's actually a variable in the numerator. Do you see that? Horizontal asymptotes are easy to find here when they're degree, same degree. This will be fun to watch. All right. So this is degree 1. This is degree 1. Do you see that? Go away. How you get the horizontal asymptote is you just take a fraction of the leading coefficients. Done. So if they're the same degree, you take a fraction of leading coefficients. And if you're like, Mrs. Lepp, why does that work? Limits in calculus is why it works. So you learn next year why that works. But not this semester. Next semester. It is next year. It's 2025. Boom. So, this is our horizontal asymptote, our half, some might say. X, not x. Y. Y equals a half. So do you see that? Do you see the difference? Yeah.
Is it only for like the largest degree, or is it only for that degree?
So if you have degree 2 over degree 2, it'll still work because you'll end up with a point of discontinuity that'll cancel off, and then just this same thing again, a rational leftover in this fraction form. So it's when the degree of the numerator is the same as the degree of the denominator, always the leading coefficients will end up being your horizontal asymptote. So degree 1 over degree 1 or degree 2 over degree 2. Okay? So we know our range then is y such that y can't equal a half. Y is now in the reals. And in interval notation, negative infinity to a half, round bracket, or a half to plus. Now, if you give set notation and they ask for interval, you get no marks. If you give them interval and they ask for set notation, you get no marks. Sadly. Okay, we're going to flip over. Due to time constraints of it being Friday, we're not graphing this. So, h of x equals f of x, which is x squared minus 9 over x minus 3. Is the degree of the numerator the same as the degree of the denominator? No. So are we going to get that fraction thing going on like we did in the previous one? No. Now, I know that x can't equal what? Somehow became an eraser. X can't equal what? X can't equal 3. Who's saying it? I just don't know if that's a vertical asymptote or a point of discontinuity. The top is the difference of squares. True statement. So let's factor it out. It's a vertical asymptote, it doesn't cancel. It's point of discontinuity, it does. If you have a squared anywhere in your question, you should factor that. Okay? The top is the difference of squares. The square root of x squared is x, square root of 9 is 9, and there's a difference sign. So I'm going to get x plus 3, x minus 3 in the numerator. And then x minus 3 in the denominator. Ooh, what's happening here, peeps? We have a point of discontinuity. Those things are canceling. And what type of graph is left over? A line. So technically, h of x equals x plus 3, but what do I have to follow behind with? Because x plus 3 is the whole line. So if you actually graph x plus 3, you'd be wrong. Because I need x plus 3, but what? What do I state behind it? X can't equal 3. That's actually the graph that's left over, right? The graph that's left over is the line, x plus 3, but where x is equal to 3, it doesn't exist, so we haven't opened up. That's what that's saying. Okay? Does that make sense? So that's how you're going to have to draw the graph. If you just literally write x plus 3, you're wrong. Because it's not the line x plus 3. It's the line x plus 3, but at 3, there's an open dot. Okay? So domain is really easy. The domain is x such that x can't equal 3. X the down in the reals. We agree? We also agree that we have a point of discontinuity, which is actually labeled quite nicely because it is a point of discontinuity. It makes the graph not continuous. Correct? That point immediately crushes our graph from being continuous. There are parts of the graph that's continuous, but the entirety of the graph is not continuous. Okay? In calculus, we'll look at portions of a graph. We can say this portion is continuous, this portion is continuous, but here it's not continuous. Okay? All right. So it's a point of discontinuity. Cool. That point of discontinuity is at 3 and something. Getting that something is that standard of excellence that I talked to you about, right? But it's the standard of excellence that you guys should throw a party for because it's the easier thing to do. How do I get the y value? Plug it into the x value. This is where people run into problems with. Most people know to plug it into the x value, but they'll plug it into the original. If I plug it into the original, I'm going to plug a 3 and I'm going to get a 0 in the denominator, and you guys are going to tell me it's undefined. And then you're stuck. So I can't plug it into the original. I can't plug it into the second step because there'll still be problems. Where do I plug it into? Your end equation, right? This one here, where the point of discontinuity is taken out. So I say h of x equals 3 plus 3. So what does it equal? 6. So my point of discontinuity is at 3 and 6. Is that a hard concept? No. But if you plug it into the first two, do you see how you're going to run into problems? And you're going to be a sad little duck on your test? So, that's a standard of excellence. That, to me, is the best standard of excellence question you could possibly be given in 30-1. See, people still do it poorly. Okay? So if I ask for the range, it would be the same thing. I have to find that y. My range is going to be y such that y can't equal 6, because that is the point of discontinuity. That is the y that doesn't exist. We agree? I know the domain and range is in C down there, but I just bumped it, so it doesn't matter. So example 4 asks you to multiply 2 and then divide 2. Give me the domain and range. Can you guys do that, please? I have this written down. So we're doing this. Okay. So this one is going to be y equals x plus 1 times 2x plus 1. A linear times a linear is going to give me a quadratic. I know my domain right off the bat because both of them it's x. Oh, this is so amazing. I love that it's doing this all day long. The domain is going to be xer, or negative infinity, positive infinity, and interval notation because it's a linear and a linear. Yep. Oh. Still going to be x here. Wrong function. All right, cool. And that, my friends, is how you make a mistake on tests. Oh, it's going to be cubic. Even easier. I don't know why I'm excited about this. These notes I use all the time. Very excited. All right. Y equals 2x cubed plus 7x squared plus 3x. Boom, boom, boom. And then boom, boom, boom. Plus 2x squared plus 7x plus 3. Why is it exciting that it's a cubic? Because it's y here. It's discoing, right? Yay. All right. Okay, the next one, we're going to get a degree 2 over a degree 1, correct? Whenever that happens, we get ourselves a point of discontinuity in 30-1 math. When you get to calculus, you get slant asymptotes. We aren't allowed those in this, so that's great. So h of x is 2x squared plus 7x plus 1. What a slant asymptote is just a line that isn't horizontal or vertical. It's like a slant. So it's a line. It's just not a horizontal or vertical line. Not an x equals a y equals line, an actual line. Nothing to read. All right. And then g of x is 2x plus 1. Back to this, we get 2x squared. What plus me 6? Plus 1x plus 6x plus 3. X, 2x plus 1. Plus 3, 2x plus 1. Where are my equal signs? Oh my goodness. 2x plus 1 can be GCF'd out of both terms, and then x plus 3. So we get y equals 2x plus 1. Oh my goodness, there's one on the top and one on the bottom. Weird, crazy that that's happening. What am I getting? Point of discontinuity. So I'm going to get y equals x plus 3, but x can't equal negative a half. So I have a point of discontinuity at negative a half and something. Where do I get the something from? Plugging it back into here, correct? This last equation. So y equals negative a half plus 3. So So it's going to be 2.5 or 5 over 2. Now this is a line at x plus 3, but with the negative a half and 5 over 2 as my coordinate. But that doesn't exist on the graph. Good. All right, domain. This little blue box is so fun. I just like it so much. So awesome. I wish it would just pop up all the time. All right, range. Y such that y can't equal 5 over 2. All right, flip over. Okay, this one, remember when it gives you a specific x, you're going to get a specific y, and then what you're actually getting is just a coordinate on the original. That's it. Okay? You're putting in an x, you're getting a specific y, and you're getting a coordinate. All right. So if we have f times g of negative 1, I don't like it written like this. I'll always rewrite it as f of negative 1 times g of negative 1. So what we're actually doing here, guys, is we're getting the coordinate on f times g, that graph. That's what we're getting at negative 1. So if we do f of x times g of x, we're getting the entire graph of those two functions multiplied. We agree? But if I do f of negative 1 times g of negative 1, I'm literally getting one coordinate off that graph. Do you see the difference? Because it's very important to notice the difference. One is the entire graph, so I put nothing in for x. The other, I'm just getting a coordinate off that multiplication graph. Yeah? All right. So f of negative 1, I go to negative 1, I follow it up to f, and I get 4. Times g of negative 1, I go to negative 1, I follow it up to g, and I get 3. So my answer is 12. The answer they're going to look for is 12, correct? But what did I actually find? The coordinate negative 1 and 12 on the graph of? Yeah, f of x times g of x, right? Okay, this one's a division. F of 1 over g of 1. F of 1 is 4. G of 1 is negative 1. So it's negative 4. I want you to tell me, where would an asymptote occur? Would there be an asymptote or anything on this one with the division? When do you get vertical asymptotes? When you divide by what? 0. Exactly. So if I did the graph, everyone's paying attention to me? F of x over g of x. If this was the graph they gave me, where this equals 0, I'm getting myself some vertical asymptotes, correct? So I would go to where g equals 0, boom. That would be a vertical asymptote. We agree? Okay. What about if I do g of x over f of x? Would the vertical asymptote stay the same? No, it's now going to be where f of x equals 0. So my vertical asymptotes would be here. Ooh, that's not a straight line. Pretend it is. And here. Does that make sense? So it's where you would get that division of 0, because you can't have that. So it doesn't matter which one's on the denominator. All right. Now this one actually doesn't just give us f and g, it gives us h, and we have to find f or g. So h of x is x squared plus 3x plus 2, and it equals f of x, which is x cubed plus 6x squared plus 11x plus 6, all over g of x. And I want g of x. So the easiest way to solve for a variable is to isolate it. Yeah? Yeah, das ist gut. So how do I isolate that g of x? Bring that bad boy up by multiplication, and now what's beside it, I bring down for division. Yeah. Some people are like, I swapped them. But why do you swap them? I don't know, I swap them. You swap them because g of x gets multiplied, and then it's going to be multiplied by this, right? And then that'll come down by division. That's why, not because you swapped them. But if they asked you for explain why and you said I swapped them, that is not explaining why. Okay, polynomials. Whoop, whoop. Who could think we could get here today? Me. So excited. All right, so I'm going to get g of x equals, the top I need 2-factor. The bottom I need 2-factor. The top is a polynomial. I'm going to have to factor by what? Synthetic division. We agree? One of these bad boys is going to cancel off. So if I were guessing, if someone took away my calculator, I would try -2 or -1 and see if they synthetically divide. Yeah? I'm going to try -1 first. So I have count, rocket count, 3, 2, 1, 0. Works. Drop the 1, -1, 5, -5, 6, -6, 0. Woohoo! So my factor is x plus 1, and my other thing is x squared plus 5x plus 6, which factors to x plus 2, x plus 3. So the top is x plus 2, the numerator, x plus 1, x plus 3. So g of x actually has 2 points of discontinuity, doesn't it? Shawapa. Goodbye. G of x equals x plus 3. Technically, x can't equal plus or -1, -2. Okay. So much fun, guys. Really fun. A blast. So fun. All right. This one has just a P by the Q, so it gives you points on P, it gives you points on Q. It says that P and Q are XER, so they keep going. These are just some points that lie on here. They want to know which must lie. And we have y equals P times Q of x. Technically P of x times Q of x. And I can only compare them if they have the same x's. We agree? So we have 7 and 7, so we're going to multiply these. So 7 and 7 would result in 7 and 24. This one would result in 9 and 48, because you do the operation to the y's and keep the x's. This one would result in 4 and, I don't know why I just circled the 4's and didn't on the other ones. 4 and 3. Which one is there? Voila. Your homework is to do this question, it's the practice diploma one, and then these.